Yes. Okay. We were in this level when we were close the last class. Okay. I was discussing with MapReduce concept, and then in the MapReduce, what are the different applications as well as functionalities can be adopted, and where MapReduce can be applied has been discussed here. As I was mentioning earlier, map and reduce would take a stream of data, enormous size of data, and combining the common data together, segregating data with respect to certain key as well as values would reduce the complexity of search and modify, search and find different elements of interest. It is a sort of opinion mining or text mining would help in analysis of data. For data analytics, big data, Google file system data, Hadoop data would be used. So because of this, Google has developed this MapReduce algorithm, MapReduce method or MapReduce programming module to analyze unstructured heterogeneous type of data. So with the use of map and reduce method, we can do lot of text-based search and operations. Among them, distributed grep is one such operation. As we know, grep is an operation which will be used to search a particular pattern of string, pattern of characters in a set of strings. It's a very fast method in Unix operating system. We use this. I was mentioning, suppose you want to verify the command which you have used earlier. Maybe you have forgotten part of complete command is not remembered from you, but part of the command is known to you. In that case, you can search the command from the history by generating history to a file. As you know, Unix works with files. So history can be redirected to a file, and then you can grep a particular pattern in the file. This was the example I was mentioning in the last class. Using map and reduce or map reduce programming model, we can do a better way of searching, which is a distributed grep command. In the regular grep command, which performs the recognition of patterns within the text streams, and it is performed across a wide set of files. MapReduce will be used to provide a parallel and a faster execution of this operation. You can recall one algorithm which you have implemented in your algorithms theory, design of algorithms, design development of algorithms, analysis and design of algorithms. Maybe in third semester, fourth semester you have studied. Finding the biggest and smallest number in a large set of numbers. How did you solve it? Can anyone open the mic and explain? Have you recalled divide and conquer technique? Someone is answering. Try answering. Divide and conquer technique. The whole set of data is being divided into two parts, and then again it is divided into two parts. Like that, a recursive algorithm will be called until you get only two numbers. Those two numbers, either one is bigger, another one is a smaller number. So then it will be aggregated to the, a tree will be constructed for this with the set of elements, and then these values will be moved upwards until the root. At the time when you come to the root level, then you will have a minimum number as well as the maximum number out of so many numbers. What is that? It is actually, it is a basic version of your MapReduce algorithm, nothing else. So in this case, what happens in a map, they will map to certain criteria, and then they will reduce the similar criteria. Items are being combined together, and then the number of items will be counted, and then that is the reduction operation or reduce operation. So in this case of distributed graph, it will be taken, a large amount of data will be taken, and it will be applied with the grep command in a distributed manner, and it will be reduced to get how many such elements have been grepped, how many such elements have been seen in a set of items. For example, you have messages in your mobile phone. Thousands of messages are there. How do you search them? I can tell you one more interesting point here. Update DB is another command in Unix. Do you remember that? Update DB. Have you ever used update DB? Update DB is a command which will create index file for the entire data. And then you can start searching where is command, or you can do grep command. You can do search and replace commands which are available in Unix shell. Similarly, suppose you do the same thing in Windows operating system. Suppose you have plenty of files to search. It will take a lot of time to search. But with the same command, Unix will get you very fast, because they would have used any of these techniques to index the file first and then to search them. So this is the facility where it has been adopted to the large amount of data, large amount of stream of data using the MapReduce concept. Next one is count of URL access frequency. As you know, search engines will give you a lot of log files. The size of log files will be in some gigabytes or terabytes. That should be searched. How many people have searched a particular website? Maybe the question of interest. Then MapReduce can be used to get this value very fast. MapReduce is used to distribute the execution of web server log parsing. So log parsing will be distributed. Web server log is very large. That will be segregated into pieces, and MapReduce will be applied there, and then it will be aggregated to get or assembled to get a single answer. So map function takes as input a log file and emits into output file a key value pair. For each page access recorded in the log, the reduce function aggregates all these lines by corresponding URL, then summing to the single access file. So how many people have accessed GCS and AC.in during this period would be getting you the number. Third one is a reverse web link graph. The reverse web link graph keeps track of all possible web pages that might lead to a given link. So that's a reverse engineering is applied. Reverse engineering is applied. Maybe it is always known. Suppose you want a very hot topic of today, current affairs. Simply you type one word, automatically everyone will try to go to that particular web link. Is that right? So you know which are the hot topics today. You, while going, if you search in your Google search, or Amazon search, whatever, Microsoft search or GoDaddy, wherever you go google.com, just you can get, a particular web link which will lead to a particular website. So this can also be done using MapReduce concept. The reverse web link graph keeps track of all the possible web pages that might lead to a given link. The input files are simple HTML pages that are scanned by map task, emitting the target as well as the source. From the source to a particular target. Okay, pairs for each of the link found given in the web page source. The reduced task will collect all pages that have the same target. Okay, so that is the idea. Next one is term vector per host. Term vector per host. The term vector recaps the most important word occurring set of documents in form of list, word as well as frequency, where the number of occurrences of a word is taken as a measure of its importance. MapReduce is used to provide a mapping between the origin of the set of documents as well as host component of the URL of the document, corresponding term vector. In this case, the map task creates a pair of host as well as term vector, and reduce aggregates the term vector corresponding. So it will count. Reduction is actually counting the number of items in the map output. Okay, so look at it. Inverted index. This is what I was mentioning. The inverted index contains the information about presence of word in documents. It is interesting. Instead of making index of a particular file, you do index of a particular word in all the files. So create a linked list of files, links, where for a particular word. So that is inverted index method. Distributed sort, which I was mentioning just now. You have studied various sorting methods in your analysis and design of algorithms. So distributed sort is again, it is used to parallelize the execution of sorting operation by dividing the elements into different pieces, sort them, and then they merge them. So you can think of merge sort method for this. Okay, you merge sort method, how do they do it? They divide into pieces, they sort it, and they will merge. What is the time complexity of a simple merge sort algorithm? It is a n log n time complexity. Otherwise, it will go to n square time complexity, but optimum time complexity or the worst case time complexity are not worried. We are understanding the optimum time complexity. Okay, so best time complexity or the average time complexity would be n log n when you look at merge sort. If you do a distributed sort method, then it would. We have already seen similar type of execution in our threaded computation, because when you applied with the thread, how much time it has taken. Well, without thread, how much time it has taken to multiply two matrices of large size we have done. I have been telling you since the beginning that program which you have executed would help you in understanding total concept of cloud computing. That's why again you go back, understand those who have taken the program from internet source and just compiled and executed, look at the way the program has been written, and maybe you can think of developing a distributed sort method also in the due course of understanding how map and reduce can be used for sorting large set of data. So there are multiple examples given here for application of MapReduce. MapReduce can also be used with some adaptation to solve wide range of problems. Interesting problem, interesting example, is machine learning, where people can apply MapReduce concept to understand, because machine learning is cognition and recognition. So cognition, recognition, you call it as. when you are doing cognition, the information should be stored in the machine. It is something like called machine learning phase. So you need to learn the system and then it will try to understand. Okay, so either in a natural language processing or by feeding different types of data or by taking different types of quiz for making the system to understand the problem. Using that knowledge, machine will dissipate, machine will understand the words you are inputting, the voice you are inputting, then it will give you some result. So machine learning also, you can use map reduce concept. Statistical algorithms like support vector, SVM, okay, support vector machines, linear regression, Naive Bayes, because the queuing, probability and queuing theory also, people can use MapReduce concepts. Neural network also people can use MapReduce concept, because MapReduce is very, very interesting area of research. People can use MapReduce. One of my research student is also working in Hadoop data as well as MapReduce concept to do his research on big data analysis. So Yahoo Hadoop cluster has been used to compute 10 raised to 15 plus 1 bit of pi, that is pi raised to 51. Hadoop is an open source implementation of MapReduce platform. So Hadoop is using MapReduce concept in a form of FOSS, free and open source software. In general, any computation that can be expressed in the form of two major stages can be represented in the terms of MapReduce computation of MapReduce evaluation. These stages are analysis and aggregation. You can think of analysis as a map task, aggregation is a reduction task. So Bayes method is something like what I feel, in my opinion, it is divide and conquer method only, which you have studied in third semester. We are explaining again with a different name, that's all. So, first you divide the data and then you combine data, divide and conquer method. So recall the methods which you have studied, recall the knowledge you have got during your earlier stages of your degree. Okay. So other variations and extensions of MapReduce is Hadoop. As I told you already, Hadoop is the open source method for MapReduce computation. Okay, MapReduce platform. Here is one example given in 8.17, Google MapReduce infrastructure overview. You look at that picture for your continuity. Okay, Hadoop, Apache Hadoop is a collection of software projects for reliable and scalable distributed computing. Next one is Pig. Pig is a platform allowing the analysis of large data sets. Developed as an Apache project, it consists of high-level language for expressing data analysis programs, coupled with infrastructure for evaluating these programs. Hive is the next one. Hive is another Apache initiative that, look at it, every MapReduce platform or variations have been here, extensions have been developed with the concept of Apache only. So Apache initiatives are there everywhere. So once you say Apache, Apache is there with Linux. So that's why whenever we discuss about web programming, we always say install Apache server as a web server, because all our transactions will be through web only. So you should know better understanding of the Apache server. Hive is another Apache initiative that provides a data warehouse infrastructure on top of Hadoop MapReduce. Okay. Next one is MapReduce and merge. So again, look at it. Merge came here. So divide and conquer, I was uttering many times. MapReduce merge is an extension to the MapReduce model, introducing a third phase to the standard MapReduce pipeline. Okay, merge, in the merge phase, what happens? That allows efficiently merging data already partitioned and sorted. So you have partitioned to distribute the work to different locations. Then you have taken it, you have sorted, and you have to merge them by map and reduce models. So map, reduce, merge framework simplifies the management of heterogeneous related data set and provides an abstraction able to express the common relational algebra operators for handling this data. So the heterogeneous data is making it as a homogeneous data in some criteria, not with respect to the type of data, in some criteria that has become homogeneous. Your similar concept has been taken in our previous finite automata class also, where similar states are merged together. Even though states are different in nature, those because of the input state and the output state, we have separated and then we have merged together to get commonality in states depending on the input. So same thing, everywhere we are applying. Again, for this particular type of data, we wanted map, reduce as well as merge. Okay, so next one is Twister. Twister is an extension to the MapReduce model that allows the creation of iterative execution of MapReduce job. With respect to the normal MapReduce pipeline, the model proposed by Twister proposes these points. Please note this. First you configure map, then configure reduce. For each case, until some condition is true, continuously do this operation, MapReduce, run MapReduce, apply combine operation. So divide, conquer, divide, conquer, divide, conquer, as well as you update the condition. So this is continuously done until your final result is reached. So these are very interesting things. You can elaborate more on this. Those who are, some of you are asking for seminar topics. You have lot of information here. You can get a new concept in MapReduce only because we are just giving you the overview of this data. So you can take some of these concepts also. What is the latest advantage, latest advancements in Hadoop as well as MapReduce, how people are using it, in which area it is being used. All this can be explored more by taking various documents, literatures, IEEE papers, and you can come with some proposal to do some seminar. This is also there. Like this, you can search many such operations. No one knows about Google file system. Google file system, how actually it is implemented, how actually you need to go to the underneath of your operating system, underneath of your file system. You can explore more about it and you can explain. What we say, it should not be, that concept should not be studied in the regular course, but this can be used to understand, and then you explore more about it, and then you can take up one of these concepts as seminar topics. This is, generally I am speaking, I am not speaking to only my batch of students. For everyone, you have to go like this. People are asking, sir, how seminar topic should be selected? You can, don't directly try to download a PPT. Try to download a paper which has been already published in a reputed journal, IEEE, Science Direct, wherever, indexed journals. You can search, download the paper, try to understand and present it. How people have developed it. It should be developed, it should be presented like the people who have written the paper should be acknowledged properly, and then you present those topics in your presentation. So next is alternatives to MapReduce. So these are the earlier was the extension to MapReduce. Now apart from MapReduce, which are the other types of methods available need to be seen. Sphere is the next one. Sphere is the distributed processing engine that leverages the sector distributed file system. See, SDFS. SDFS, we have seen Hadoop database file system, data distributed file system. GFS, Google file system. Here now sector distributed file system. So in this case, rather than being a variation to MapReduce, Spear implements the stream processing model. The data is taken as a stream, it is processed as a model, as a file system. Okay, so single program multiple data, they call it as single program multiple data, SPMD data, and allows the developer to express the computation in terms of UDF, which is user defined function, which are run against the distributed infrastructure. Okay, stream data file system. A stream is a data structure that provides access to collection of data segments mapping one or more files into the SDFS. A specific combination of UDFs allows Spear to express MapReduce computation. Next one is Next one is dry add link. Dry add link. Prior to that, we have one more method called all pairs method. Please note it. It has not been mentioned in the PPT, but anyway, please note this page number 2.0, 8.20. All pairs. All pairs is an abstraction and runtime environment for the optimized execution of data-intensive workloads. It provides a simple abstraction in terms of all pairs function that is common in many scientific computing domains. Example of problems that can be represented into this model can be found in the field of biometrics, where similarity matrices are composed as a result of the comparison of several images containing subject pictures. So you know already multiple even you are giving Face ID in iPhone or biometric data in other phones and thumb impression in other phones, multiple images are taken and then it will reduce into a single image for a pattern search, a pattern recognition. Similarly, here also it is all pairs is a similar type of algorithm where for each set of items in SI, for each item in SA, you can submit a job, S1 as well as 2. Here in the algorithm 8.20, they have used $I and $J. That is the input which has been taken. Now I have given you set of items S1, SI and SJ. You can think of like that also. You have two sets where you can, for each $I in A, for each $J in B, submit job of $I and $J is the algorithm which is given. Now, Dryad Link is a Microsoft research project investigating programming model for writing parallel and distributed programs to scale from a small cluster to a large data center. The aim of Dryad to provide an infrastructure for automatically parallelizing the execution of applications without requiring the developer to know about distributed and parallel programming. Okay, so in Dryad, developers can express distributed application as a set of sequential programs that are connected by means of channels. More precisely, Dryad computation can be expressed in terms of a directed acyclic graph in which nodes are the sequential programs and vertices represent the channel connecting such programs. So next is 8.3 Aneka MapReduce programming, which I think we can continue in the next hour. Let me go through the entire PPT again. Just those who have missed out my classes can see this 8.2. In 8.2, we have discussed many technologies which are related to data-intensive computing and how data-intensive computing can be applied with a large amount of data. So we need to develop techniques where the size of data is enormous. So then when data is more, we need to think about storage systems. The normal DBM as a database management system would not sufficient to store a type of data because the data is in the form of non-similar data or heterogeneous data or a different type of data, but it should be handled from one file system. So relation database management system is not sufficient to handle, but other type of file system, normally these are considered to be normal files, no structure, unstructured data. So there will not be any structure in data. There will not be any type of data which can come as input here. So because of various factors now, and also the way people are using data, they are producing data, they are supplying data to such algorithms, which is considered to be big data, and growing importance of data analytics in business chain, because do analysis is very important to analyze pattern of data, and you can understand the sentiment of the person who is in the chain, business chain, and then you can analyze and you can take some business continuity planning. That's why we need to understand how data to be saved when in case of large amount of data. Storage system we have seen, okay, and then advances in distributed file system, because when we have a large amount of data, single system cannot handle such amount of data. That should be segregated into multiple locations, then comes with a distributed file system. So each node which is connected into the network should be capable of handling, should be capable of processing data which is being supplied. That is where you will understand distributed file system and also the infrastructure required for handling that. Till now, we were working with SQL based database, but now you do not have a SQL, you have no SQL, or it is also known as not only SQL. So all these things we have seen. So there are multiple storage clouds available, okay, and then we have let's try, we have GPFS from IBM, and then we have a GFS from Google, and then Sector, Amazon Simple Storage Service, we call it as S3, and then we have a NoSQL system, that is not only SQL. Why only SQL? Not only SQL is next one, and then we have so many NoSQL implementations in the document store, graphs, multi-value databases, object databases, and tuple stores. And then we have Apache. Apache come into picture because wherever you go, Apache is there as a backend, as the building foundation. Okay, Apache CoachDB, Apache MongoDB are very important document stores. Then Amazon Dynamo is another one, which is a distributed key value store, which can be used to handle large amount of data. Other examples which I have seen: Google Bigtable, Apache Cassandra, and Hadoop HBase. Later we have seen this MapReduce programming model, how Map and Reduce are working, and these are the things from today. We have seen this Hadoop, Pig, Hive, MapReduce, Merge, and Twister, alternative to MapReduce also. I'll conclude my class now here. If you have any queries, please ask me. I hope you have understood the topic today, and you have got some thinking about implementing data analytics algorithms in your future course of projects. And also I have told you about how to select a seminar topic by looking at various literatures available in the internet. Do not try to download PPTs. Do not try to download reports from internet, where you will never learn something which is new. You have to learn something which is new, and you have to make your audience to understand the concept. You have to make that topic is so much of interesting topics available in that. Okay. Thank you very much for patient listening. Bye.